Hey, Danilo.
Hey, nice to be
Good.
here.
Yeah, great to see you. Before letting you in, just a short introduction of your person because it's worth of mentioning about your achievements. As you probably know, if not, better sing that up. Danilo is a chief evangelist in EMEA region at AWS, and by leveraging his experience, which is huge, he helped companies, people to bring their ideas to life, mostly focusing on serverless architectures and event-driven programming. If you don't know, he's also the author of AWS Lambda in Action from Manning. The floor is yours. Great to see you, Danilo, once again, and thank you for being with us.
Thank you. Thank you for having me and thank you for organizing. It's always great to have this moment of community where we can share now the status of serverless. And today I decided to focus on something that is a little bit more peculiar than my usual topics because I'm talking about containers in a serverless event. And the idea is to understand what's the value that container images can provide for serverless development. And first of all, I will start this session introducing the why and the how container images can be useful with serverless functions. I will do a very quick look at the tools, the tooling, what you can use to be fast in using container images for your serverless development. And then I want to jump into the focus of this presentation. I often hear people saying, no, if I develop a function, a serverless function, then it's difficult to move that into another environment. I want to show how it's relatively easy, especially for web application, to create a single container image that can run as a serverless function and also in a traditional container environment. So let's start with container images and when it makes sense to use them with serverless functions. When you create a function, for example, with Lambda, with AWS Lambda, part of the magic is that you just give the code and then the provider, no, AWS Lambda in this case, is doing everything, is managing the operating system, is managing the runtime to execute your Node.js, Python, or whatever code, and it's managing the scalability and everything for you. But sometimes there are some reasons where the zip file approach, so just providing the code, is not the best. And there are two categories of reasons. So the first category is if you're standardizing on containers in your development workflow. So maybe you work for a company that is using container images as the standard artifact that is created by development and then passed to test and then to deployment in production. If you use many tools, maybe for CI/CD or automatic test or for security that use container images as their natural artifact, then again, it's much easier to continue to use these container images instead of using another artifact like a zip file. And the second category of reasons is managing dependencies. So if you create the classical hello world with a Lambda function, for example, it's very easy to get live and start in just a few minutes, if not seconds. But if you start to install dependencies, things get a little bit more tricky. And there are some dependencies that depend not just on the runtime, but also on the operating system. For example, if you use Python for machine learning and you want to run machine learning inference inside a Lambda function, you need to install a tool like PyTorch or TensorFlow that requires NumPy. And NumPy is a library that normally requires some low-level system libraries to execute the mathematical computation very quickly. And that's something that is not so easy. In fact, we have a standard layer that you can use for that is managed by AWS. But with containers, you can do that very easily because you can install with NPM, you can install with pip, you can install with whatever operating system tool you have to install additional packages. And also, we are giving a lot more space for container images because with the zip file, the maximum size when you extract the zip file, including all layers, is 250 megabytes. But with container images, you can create container images up to 10 gigabytes and deploy them for your Lambda function. And the reason is that with zip file, we extract the zip file in the execution environment that is used by the Lambda function, in the multiple execution environments that can be used now if you have concurrent executions. With container images, we're doing something a little bit more tricky. We are actually taking your image, you're optimizing the image, we're looking into the layers inside the container image, and then we're sending only the bytes that the execution environment really needs. It's hyper optimized, so even if the image is very large, only when you need something it's sent to the image, and it's very highly optimized, so that at the end the cold start of a zip file or a container image are comparable. And to use a container image, you create for a Lambda function, you create just use just a Dockerfile like you would normally do. The only difference is that you need to use a container image that can talk with the Lambda platform. So to simplify that, we provide you base images for all the runtimes that we support, like Node.js, Python, and .NET, and so on. And then you can copy your application files, your configuration files. You can run all the operating system commands that you want, including in this case, npm, pip, or you can install a rpm file. This is an Amazon Linux, so it can install RPM files very easily. And the only difference with a traditional Dockerfile is that at the end you have to provide a command that is the handler of the function, similar to what you do when you configure a Lambda function with a zip file or providing directly the code. And the handler is, as a user syntax, where it's the name of the file dot the name of the function inside the file that we will invoke when the Lambda function receives an invocation. These base container images that we provide simplify you to create this flow. So basically, with a container image running inside Lambda, you have to provide your code, but your code needs to speak with the Lambda platform. So you need what we call a runtime interface emulator. This runtime interface emulator is running your code and is implementing the runtime API. This is a public API that we published that you can use to create your custom environments. And this runtime API is the API that the Lambda platform will use to run the invocation to your code, and then also to understand if there is an error and to other more advanced things. We provide you the base images that include the runtime interface emulator, but if you want, you can also create your own base images. We provide you the runtime interface emulators for all the runtimes that we provide, that you officially support, so that you can download and add them inside your container images if you want to go the custom route. Also, we provide you a runtime interface client that allows you to quickly test. It's a sort of HTTP proxy that translates simple requests to invoke your Lambda function, so that you can invoke your functions very quickly, also locally or through a toolkit. The runtime interface client does not depend on the runtime you're using, so there is a single one. And again, you can install it if you want. We provide you the tools to install it on top of your custom image if you want, or it is automatically included in all of our base images. And our base images are available in Docker Hub and in the ECR public. I'll show you that in a little moment. When you have this container image, you can also test using the RIC, the function locally, and you can just use Docker run to start the container. The runtime part included in the image will emulate Lambda. The RIC will talk to the runtime environment and will provide you an HTTP interface that you can use to invoke the Lambda function locally. And this is the syntax of Docker run. At the end, you put the name of the container, image, and the handler if you want to override the one that is configured in the container image, the network ports, and you can pass environmental variable. So you can pass environmental variable to pass the name of the DynamoDB table that you want to use, for example, or you can pass also the AWS credentials or the AWS region to use. And this is a nice trick to use, for example, the AWS CLI to pass your credentials automatically to the Lambda function running inside the container. In this way, you can run the Lambda function locally, but the Lambda function has the permissions to connect to a real DynamoDB table, to use maybe a real SQS queue, and in this this way, you only move the execution of the code locally, but you don't try to emulate the whole AWS services locally, because as we also saw with the other speakers today, it's just complicated and it doesn't really pay. And then you can invoke your function locally, for example, using a tool like curl. This is the syntax that you should use. It's the same syntax of the runtime API. And at the end, you see this empty curly brackets. That's the payload that you want to pass to the Lambda function. So you can pass any custom payload you want, and then you get the return. As I said, we publish these base images that you can use on Docker Hub and also on the public gallery of ECR, the public ECR. It's our container registry. And here you can see there's all the supported runtimes. And for each supported runtime, now you have both the x86 version and also the ARM version, because since a few weeks, Lambda can also run on ARM using the Graviton 2 processor. And this is another way to optimize your application, especially for cost. So it can be faster and cheaper. In the blog post that I link here, I described a few ways in which you can test, maybe in parallel, to move a little bit of traffic, maybe 1% of your traffic onto ARM, and then you can use tools like Alex Casaboni Lambda Power Tools to compare the results. And depending on your application, you might just need to change the base image, like I did in this example, to be the one for Node.js 14 for ARM, and everything else comes automatically. Many tools simplify the implementation and the use of container images for AWS Lambda. It's integrated with AWS SAM, so you just need to specify that the package type is an image. You can optionally override the command. So in this can be handy because you can create a single container image with multiple functions inside, and then overriding the command helps you trigger different functions inside the container image. This can simplify the deployment because you have a single container image that can fulfill multiple functions. And this is useful, especially if you have multiple functions that share a lot of code together. And then you have to pass also the metadata section to SAM to pass the name of the Dockerfile, the location of the Dockerfile, and optionally tags that we will add when we create the Docker image. This is also supported by the Cloud Development Kit. So with AWS CDK, you can create a Docker image code construct that contains your code as a Docker image, and then you can use the Docker image function to pass this as a parameter. So it's relatively similar to what you would do for a normal function. You just have to use this Docker in the name of the construct, and again you can override the command to take advantage of having a single image used by multiple functions. Also, the serverless framework implements something similar. So you create a provider for AWS with the images that you want to use, and then you can pass these images to your function. So you specify the image parameters. So this was a very fast introduction to how you can use container images with serverless functions. But let's go to the core of the session. How can we use container images with both environments? So what I mean is two things. So the first approach is that you want to use the same application code, and then your build process can create two container images. One goes to the Lambda environment, where users can invoke your API gateway, and then this will reach your Lambda function that is using the container image. At the same time, your build environment can create a slightly different container image that is deployed as a container. You can use any tool you want. You can use CCS, you can use Kubernetes, you can deploy on-prem or in a cloud provider. And then a user going through probably a load balancer for availability will reach one or more containers running your application and will interact. As I said before, this works for web applications and can be extended to other kind of invocation with some more additional code. But for web application, is quite neat. The second approach, and it's the one that I'm trying to do today, is to create a single container image. And the same container image can be deployed to Lambda and to any traditional container environment, and then can be used to serve web traffic, so like a web API or even a traditional website. To do this kind of translation of a singular container image to multiple environments, you need some code that takes your Lambda function code and translates that into HTTP request. Normally, writing this code cannot be so complex depending on your application, but luckily there are many tools that already do that for you. So, for example, for Node.js, there is the Serverless Express module that was created by AWS and now has been passed to Vendia, and it's still maintained by the awesome Brett Andrews. So big clap to Brett for his work here. And this works with many Node.js web frameworks like Express or Sails, and you can just wrap your application with the Serverless Express module and serve this through Lambda. So you create this traditional Node.js web app, and then you wrap it to run into Lambda. There's also a similar framework for Python. This works with Django, Flask, and any standard WSGI web framework for Python. Zappa is very popular and also one of the very old frameworks for Python and Lambda that I remember. And it's very simple to use. And of course, if the smaller your application is, the better it works, but it's being used also with very large applications. With container images, you can push it even further. And there's also a similar project for Java that runs with Java frameworks like Spring or Jersey. And this has been created again by AWS. It was the one person that invested a lot of time is Stefano Bugliani, who is now the product manager of AWS SAM. And with this tool, you can again relatively quickly take a Java web app and run it into Lambda with API gateway. So let's jump into a demo and see how this can work in practice. So if we go into the editor, this is the code of my application, and what we have here is a traditional Express Node.js application. So at first I declare a static path here. So the static path is mapped to a directory, local directory, where I have some images and some HTML files. And then I also implement two APIs. So I can do a get on slash, and I get in return hello world, and I can do an HTTP post on slash, and I get a thank you for posting. And also I implement a redirect. So if I go on slash gallery, I'm redirected into the gallery HTML file that is in the static folder that I mentioned before. So this is a completely standard Express app. I only included this additional line to use it with Serverless Express, and that's that I want to export the app from this module so that it can be grabbed by the Serverless Express framework. So this is the code of the Node.js app. And if I go here in the FN directory, I have the wrapper. This is the Lambda function that is using Serverless Express. It's importing the application, and it's wrapping the application using the Serverless Express module. And that's it. This is the handler of the Lambda function that is exported and will translate the request from the API gateway into the request that the traditional Express framework works. There's not a lot of additional configuration that you should do. And if we look at the Dockerfile, I actually have two Dockerfiles here. So this is the Dockerfile of the traditional Express app. So I'm using one of the default node images. I'm using node 14 now. I copy the code of my application, so the code and the dependencies. I also copy the full public folder where I have the static assets. I run npm to install the dependencies, and then I expose the port. And this is the command to start my application. It's node and app.js. If we look into the Dockerfile that I use with Lambda, it's very similar. I just replaced the first line with a base image of Node.js so that I know that includes the runtime emulator for Lambda. I copy my source code, and I also copy the code of the function. And this time I'm using the dependency, so the package .json file of the function, not the one of the app. And the reason is that the package dependencies of the function is including Express, but it's also including the serverless Express module. So there is an additional package. That's the reason why I have a different one here. Then I copy the public folder, and then I use the command of the Dockerfile to pass the handler of the function. So the name of the file is fn, and then the name of the handler function is handler. So this is the handler that the Lambda platform will use to invoke this function. Now I can build both container. I have here a simple script that will do that and builds one application, the same image with the app tag for the traditional web app and with the fn tag for the function. And I can deploy these two container images separately. But if we look at the back at the Docker file of the Lambda function, this is a superset of the application because it's the application with all these dependencies plus the Lambda function, the runtime environment, and the serverless Express module. So if I override the entry point and the command, I can still run this as a traditional web container. And in fact, this is it. So the first command that you see here is how I can start the application with the traditional Express application. I just start the container and map the port to whatever I want. I'm using 3000 as network port. But if I take the function container, I just need to add this part. I need to override the entry point to start node instead of the runtime. And then I need to pass the command that is the app.js file in this case. And that's it. This is the same container running as a Lambda function or running as a web app. And in fact, I also deployed this. So if we go on this browser, we can see here that I have a Lambda function. I call this demo as you like it, because you can choose as you want to run your container. And I also have an ECS cluster running a Fargate container. So let's start with Fargate. So let's go with Fargate. I go into the cluster. I select the service and the task. I only have one task. Normally, with containers, you have multiple tasks or multiple pods running in parallel, and then a load balancer. Here I have just one. This is using the same image that you can see here. With the entry point and the command, like I shown in the CLI, and I can take the public IP, and we can go, for example, on the CLI. We can do curl, and then we can do HTTP. There's no HTTPS because I didn't implement that. And I can do a get, and I will get port 3000. I didn't change the network port, and I get hello world. I can change this to be a post, and I get the thank you for posting. And I can also go to the gallery. And if I go into the gallery, let's copy this. I get the redirect to static gallery HTML. So if we go back to the browser, I can go here, and this is my website. It's a couple of pictures that I took last week, and this is all served by a Fargate container. The good part is that if I go on the Lambda function, this is using the same image. I can go into the API gateway interface. Here I change the default integration to be a proxy integration that will map any request that the endpoint takes with any path to the Lambda function. I can copy this. I just need this path here. I can go here and I can load it. And again, I get hello world. And if I go with /gallery, I'm now serving the website through a Lambda function. So I'm not paying by the time, I'm paying by the invocation. I'm also serving the images through the Lambda function. This is probably not optimal. It's more of a lift and shift situation. And probably the next optimization would be to remove the static part, put it on S3 with a CDN like CloudFront, and then keep only the dynamic part into Lambda. But again, I'm just quickly serving the traffic. I'm showing a website here, but probably the place where this works very well is with web APIs. That's why I was showing also the curl example. And again, I can do curl on the endpoint, and I get the hello world, and I can do the post. And as you can see here, I am using HTTPS. Everything is load balanced. I can manage multiple invocations. So the beauty of serverless is still there. Everything is managed. I don't have to think about how to structure the architecture of my application. So the code of this very basic example that is still an interesting skeleton, I think, it's shared on GitHub. You can find it here, and I will also add a tweet later with the link. So if you don't have the time to grab the screenshot. And what's the takeaway? What are the takeaways? Using container images removes some of the magic of serverless, but helps you if you're already using container tooling in your development workflow, and helps you manage complex and large dependencies, especially dependencies that depend on the operating system, like NumPy and things like TensorFlow or PyTorch, for example. If you need to include graphics, fonts, anything strange into your serverless applications. And also, they can be used to serve the same web traffic through different platforms. So you can create single container images and have a single artifact that can be used with serverless functions and with traditional container environments. I hope that helps, and let me know what you think.
Okay, Danilo, thank you very much for your session. And I was watching your session and cannot stop thinking about asking you one question. And I'm trying, to get back with my thoughts. But with this step, presenting containers, I mean, giving you the ability to tweak with your container image in the serverless world, how do you think? Is it any other particular reason with presenting such feature to the serverless? Because people new to the serverless might think, okay, I have a containers in a Fargate, for example, and right now I've got the containers in a Lambda. So how should I pick right decision? So how do you think, Danilo?
Well, probably it's better to connect back to what Alex was doing in his keynote, in his introduction. When you're move to serverless, it's not just about the technology, it's about the architecture and the value that you can provide, and the cost, the pricing becomes important. So if you have this running in containers, you still have to think about scalability. You have to think about the load balancer. You need to add some SSL termination because you want to serve something with a secure protocol. And there's many things that you need to manage. You need to collect the logs, centralize the logs. Lots of management around that you need to implement. There are tools for that, but you need to take ownership. And also you pay, depending on the platform that you use, probably you pay by the amount of container running and the time these containers are running, plus the load balancer. With Lambda, you have everything managed from the scalability point of view, from the SSL point of view. The load balancing is part of the service, and you don't need logs are centralized, and then you can integrate with many very nice partners in this area. And the pricing is still by invocation. And with Lambda, you now pay exactly for the milliseconds of execution. We changed the billing last year. So if you have a Node.js application that responds in 7 milliseconds, you pay 7 milliseconds of execution of your code. So for many web applications, this is much cheaper because you can start very slow, you can grow if you have a request, you can scale down, and also for startups, I think it's perfect for implementing your initial release of a product, and then eventually you can transition to a different platform.
Okay, I mean, you're absolutely right, and Alex also mentioned that it's not only about the technology itself, but the mind shift toward the decision. If you want to take the responsibility in a serverless in other form than in traditional way, you have to change that type of thinking in your mind. So yeah, Daniel, you're right, and once again, thank you for your session.